Okay, we're recording now. And share the screen. Okay, I'm going to be done very quickly today with 1.5. There's maybe just a couple more problems that I was planning to do. And then that will be it for the coverage of the test on Friday. Okay, but I am going to go ahead and get started with some of chapter 2. Again, buffer day does not mean holiday. Okay, it's just in case I fall behind, my internet goes down, you know, all that bad stuff. Okay, so so far I've been able to keep the schedule, finish 1.5 by today. I will finish 1.5 today. So I'm going to get started with some of chapter 2 even today and tomorrow. Okay, anything I do in chapter 2 will not be covered on this Friday's test. This Friday's test is just on chapter 1. Okay, and again, I'm reserving Thursday if you wish. Thursday, I'm going to reserve the entire day for questions and answers. So if you have any questions from any of this stuff, you may ask it. I'll let you have the entire class period, but if you don't ask any questions, I'll just keep going with chapter 2 stuff. Okay, and a reminder, you have to turn in the homework. I do have a 70% homework requirement. You must turn in at least 70% of this homework. I end up doing a great percentage of it anyway, as you all know. Okay, sorry, should have set this to mute mode. Okay, sorry, somebody's trying to call me. Okay, so if you don't turn in at least 70% of the homework, I don't grade your test. I just simply ignore your test. Okay, and again, it's a little safeguard for me. I'll look at how you write the test. By the way, I already have a sample of your writing, as you know, since you've already done 2 quizzes. And well, some of you I know you're writing a little bit from last semester, if you took me last semester. Again, I'm not a handwriting expert, but I can tell some obvious things. So, you know, I'll look at your homework and the exam especially, and I have a sample from your quizzes. So if I find the handwriting on the quiz doesn't match the handwriting on the homework, which doesn't match the handwriting on the test, I get very suspicious, right? I think it's a little safeguard for me. You know, a student might get somebody to cheat for them on the test, but you're much less likely to find somebody who wants to do all of this, all the homework for you, right? So that's a little safeguard for me. That doesn't mean there isn't cheating out there. Of course, I know, you know, I'm not that naive that cheating doesn't occur. Cheating was going on even when we met face to face. You can't catch them all. But after a while, I say to students, you know, you spend so much time and energy coming up with these sophisticated cheating schemes. Why don't you just learn the material in the first place? It would be a lot easier that way. But anyway, be that as it may, I guess if somebody really wants to cheat, they're going to cheat anyway. So. And yet, you may have heard the expression, when you cheat, you're really just cheating yourself. So, you know, take it or leave it, but be that as it may. In the long run, you're just cheating yourself, and it'll catch up to you. Okay, so I will finish this. I'll get started with some of this. And I'll try to get a little ahead. And I don't know what's going to happen. Last semester, I had a whole week that I was off the internet, so I couldn't teach for a whole week. And some of you who had me last semester, you know that happened. So if I can get ahead, I'll go ahead and go ahead. All right. All right, so I'll go ahead and get started. And yeah, go ahead and put something in the chat if you wish. I won't be able to address it necessarily right away, but maybe Prasanna can do that. Okay, so I want to show you some more of these problems at the end. Okay, so I showed you 69, and then 70, 71, and 72 are kind of like that also. Okay, so I will show you that. And how do you type this on a keyboard? Okay, so if you notice for 70, it says inverse sine. 71 says inverse sine. 72 says arc. So if you're typing it, you should have arc. Okay, so maybe I can get that. I know somebody has something in the chat. Okay, so I'm typing right now arc sine, arc cosine. Okay, so if you can see that in the chat, if you have to type something in the chat, that's how you type arc sine, arc cosine, arc tangent, instead of the -1. It's a lot shorter to type the -1, but as you know, it's a little bit harder to write it. Okay, so you can do the arc stuff. Square root, SQRT, or square root. Okay, it's square root, and exponents like x squared, use the up caret. So I put that in the chat. And the up caret is above the number 6, is that right? On most keyboards, right, above 6 is the up caret for exponents, so x squared, x cubed, and so on. SQRT, abbreviation for square root. And instead of the sign with a -1 and cosine -1, put arc, ARC instead, okay? All right, so I got that over there. Okay, and yes, I see somebody just joined. I'll get you from that a little bit later. But how do you do these problems at the end now? Okay. So I did one of them for you, 69. Okay, so you basically have to do your triangle stuff. Okay, so make a triangle, do your SOHCAHTOA. We did one yesterday, and we'll do more. So 70, I'll do the evens. Tangent of inverse sine of x. Again, when you're handwriting, it's a lot easier to do this. When you're typing, then do the arc stuff. All right, so I say let this be theta. So ultimately, you're trying to find the tangent of theta, right? So theta is inverse sine of x. Rewrite it without the -1. So write it as sine. So sine of theta equals x. Again, the logic is, can I be taking the sine of x? No, you're taking inverse sine of x. So I got to be taking the sine of something else. The only thing else is theta. So sine of theta is x, which is x over 1. Draw myself a little triangle. Okay, so do my SOHCAHTOA, right? Sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. So I put a little right triangle, theta. So sine is opposite over hypotenuse. So x1. This adjacent side turns out to be radical 1 minus x squared. It's the same thing as over here, right? If I temporarily call it y, x squared plus y squared equals 1, which means a little bit of algebra, y is radical 1 minus x squared. So there it is. Okay, then we want tangent of theta. So tangent, TOA, tangent is opposite over adjacent, right? So that would be the opposite is x, and the adjacent is radical 1 minus x squared. So my final answer is tangent of theta is x over radical 1 minus x squared. Okay, that's an equal sign, not a negative. Right there. And I'll raise it up there. Okay, and then 72, sine of 2 arc cosine of x. Okay, and yeah, there that is again. Arc cosine and cosine with a -1 mean the same thing. Okay, this is easier to type on the keyboard. This is short to the right. Sine of 2 arc cosine of x. So I'm going to call arc cosine of x theta. So theta is arc cosine of x, which means cosine of theta is x, or x over 1. Okay, am I taking, say, get rid of the arc. Getting rid of the arc is the same as getting rid of -1. It's the same thing. Okay, so you say, how do I do that? Could I possibly be taking the cosine of x? No, no way. I'm taking the arc cosine of x. So I must be taking the cosine of something else. There's only one other else, theta. So cosine of theta is x over 1. So now if you look back at the original, ultimately I'm trying to find a sine of 2 theta. Sine of 2 theta, you had a formula for that from trig, right? It was a double angle identity. Sine of 2 theta is 2 sine theta cosine theta. Okay. And you say, well, I don't remember that. Put it on your cheat sheet. Put this on your formula sheet for the test if you wish. Sine of twice an angle, remember that? Sine of 2 theta is 2 sine theta cosine theta. Okay. Obviously, you're not going to be able to write everything down on your piece of paper. So some of you, maybe you say, oh yeah, I know this down pack. I know sine of 2 theta is 2 sine theta cosine theta. I don't have to put that on my formula sheet. Then yeah, don't save it for something else. All right, so now I just look at my triangle. I've got cosine of theta is adjacent over hypotenuse. Ka, right? So ka toa, cosine adjacent over hypotenuse. So I lay down x for the adjacent and 1 for the hypotenuse. And then the opposite is radical 1 minus x squared. After a while, the Pythagorean theorem ends up being the same for a lot of these. Okay, it's the same as the one I did yesterday. It's going to be radical 1 minus x squared. I put it sideways so I can see it there. All right, so now I want sine of 2 theta, which is 2 sine theta cosine theta. So sine of theta, so ka toa. So notice we're doing all of them, right? For these few problems that we've done sine, cosine, and tangent. So let's see. Sine is what? Opposite over hypotenuse. So the opposite is radical 1 minus x squared. Put it sideways there. It'll fit. And the hypotenuse is 1. So this is sine theta. And then multiply by the cosine of theta, which is the adjacent, divided by the hypotenuse. So x over 1. And of course, the ones on the bottoms mean just throw it out. So final answer, 2x radical 1 minus x squared. And we are done. Okay. All right, folks, I am now done with 1.5. I can check this off. Okay, so I am now completely done with chapter 1. Coverage for the test will be up to here. I'll get started with some of chapter 2. Go ahead and take notes, but look at it very lightly. From here on out, the rest of this week, focus on finishing the homework. And you have to submit the homework, of course, as you know. Study this. You might say, is there a practice test? This is the practice test. Just practice all of this. And if you can do these problems, you should be okay in the test. The problems that I give are just going to be just like these. Okay? I'm not promising the very same questions, but very close to the questions that you had here. There's nothing on the test that you should look at and say, this is weird, this is unusual, he didn't give us anything like that. No, everything is just like this. And how many questions do I tend to give? I usually give about 10 questions. All right, maybe 9, maybe 11, but I tend to give 10. So now if we have 5 sections, then I guess the most likely scenario would be I give 2 from each section, right? So maybe I'll give 2 questions from here, 2 from here, 2 from here, 2 from here, 2 from here. That's the test. All right, so that'll be this Friday. Okay, so I'm done with that. I will begin calculus in earnest. Okay, so we're starting up calculus, and I did, as you know, you replied to my survey earlier. There are several of you, not that many, less than half of you have had some background in calculus. Okay, so for you people that have had background in calculus, I'll speak to you only. Chapter 2, you may know some shortcuts for derivatives. You may not use any of them in chapter 2. We're going to do that in chapter 3. Okay, so if I see you do any derivative shortcuts in chapter 2, you get a 0. Okay, and so in some sense, I want you to kind of clear your slate, clear your brain of your previous knowledge of calculus, of shortcuts and so on. You may not use any of them right here. For those of you who have absolutely no idea what I'm talking about, that's fine. That's actually the way I want you to be, that you don't have preconceived notions, right, of saying, oh yeah, I know what to do for a derivative and all that kind of stuff. Okay, so the few of you who said you have background in calculus, please do not use any shortcuts that you had for derivatives, especially in chapter, in chapter 2. I'm not going to let you have that. Okay, those are going to be for chapter 3. All right, so here we go. Okay, so chapter 2, topic is limits and derivatives. I was just speaking of that. Derivatives. For those of you who have no calculus background, we will use the word derivative a lot from here on out. Okay, so we'll hear derivatives, derivatives, and more derivatives. Right now, you say, I don't even know what you're talking about. That's okay. Don't worry. We'll try to get you through that for the semester. But dare I say, the word derivative is going to come up quite often in this course, okay, from here on out. All right, so by way of introduction, I'm just going to show you some pictures. Page 78, 2.1, the tangent and velocity problems. Okay, I'm going to hold off on velocity for now, but tangent. Okay, right now I'm not giving a formal definition of a tangent, but a tangent line just kind of grazes the surface of a curve. Okay, so in your high school geometry, maybe you've had a tangent to a circle. Okay, it touches at just one point in this particular case. Okay, we're not going to use that as a formal definition of a tangent, though. Okay, so this looks like a tangent; it just barely grazes. but that would not fit my definition of touching only one point. Here it touches 2 points, but this definitely looks like a tangent. This thing does not look like a tangent, even though it touches at only 1 point. Okay, so it's a line that just kind of grazes the graph. Okay, that's not very exact. We're going to try to get it more exact, and so we'll look at that. Okay, so they've got a line L here, which is not a tangent, even though it touches at 1 point. This is a tangent, even though it touches at 2 points. So we're not going to use the idea of a tangent to say the number of points that touches the graph. Okay, we're just going to say it barely grazes the graph. Okay, and I'll just quickly add, you said you just talked about tangent in trig. Yes. Okay. Unfortunately, and this is one of the unfortunate things about mathematics, okay, there is more than one definition of the word tangent. Okay, so this is a tangent line. It does not necessarily have anything to do with a trigonometric tangent. Okay, so if you think it's kind of dumb to have the definition of tangent to be two things within the same discipline of mathematics, you're right. Okay, completely right. So the context makes it clear. So when I say tangent or a tangent line, we're now talking about this. We're not talking about the trigonometric tangent. Okay. Now, on page 79, they show you 6 graphs here. Okay, the blue lines, I see a bunch of blue lines. See the blue line here? Blue line, blue line, blue line, blue line, blue line. Okay, those are secant lines, S-E-C-A-N-T. Yes, the same secant as the trig secant, but again, it's a different definition. Okay. A secant line just simply touches 2 points in a graph. Okay. Secant. And yes, it's also dumb. Say, there's a trigonometric secant, and now you have this secant. Yes. If you take any 2 points, okay, this happens to be the graph of what? Do you recognize this graph? Y equals x squared. Okay. So if I just take any 2 points in a graph and connect it, I get a secant. So they give me 6 different graphs. Okay. But please look only at P and Q, the blue. PQ, 2 points. 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 Okay. So all the blue lines are secant lines. The red line is a tangent. Okay. Now they're trying to show you something from these 6 graphs. The red line T stays the same, it looks like, right? So they're trying to draw the tangent line at the point P. Okay, sorry, I know it's not focused, but I can't lift it up too easily. Okay, so the tangent line seems the same. Okay. The point P seems to be fixed. Okay, that P and all 6 of them are the same. And there's Q. So if you look at all the letter P's, they're all the same. That, they all seem to be the same. So what is the point? Maybe it's 1, 1, I guess. Okay. And then they have Q. They seem to be moving Q along. Right? Right. Now they don't give me this point, so what is the point? Make up anything. And so, well, yeah, let me get this out of the way. It's a real bad joke, but it happens. So I'll say it now at the beginning of the semester, then it's over and done with. Okay, so if I say, what's the point? Okay, I mean, what's the order pair? Like 3, 5 or -1, 2. Not what's the point as in, in English, what are we doing this for? What's the purpose, right? So I know some of you might be saying, what's the point of doing all this stuff? Okay, haha, bad joke. There it is, get it out of the way. So it's there, right? So if you hear me say, what's the point? It's not, what are we doing this for? Or what's the purpose? It's what's the point? What's the order pair, right? What is it? -3, 5, or is it 10, 17, or something like that? Whenever I say, what's the point? Okay, so get that out of the way. All right, now what's happening here? Q approaches P from the right. So they're fixing P, and there's the point Q, and now Q moves closer, and now Q moves closer, right? So Q approaches P from the right. Now what's happening over here? It says Q approaches P from the left. All right, so they got some point over here, and they drew a secant line, and another one, and another one, right? Now, in each case, look at what's happening for the blue line and the red line. What happens when Q moves closer to P, what seems to happen between the blue line and the red line? It looks like it's closer and closer, right? So if you look over here, the blue line and the red line, they don't look that close. But by the time you get over here, they're really close, right? In fact, if I could keep the picture going and Q got really, 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 really close, but as long as it's two separate points, right? I mean, they can be, 1 millimeter apart. It's still two different points. I can draw a secant line. It would look really, really close to the tangent line. Same thing over here. Q approaches P from the left. Okay. So in this first case, the blue line and red line, they don't look close at all, right? Secant line, tangent line. But by the time I get over here, right, I move Q along the graph closer to P. Then it looks like it's closer and closer and closer, right? And again, if I let Q get really, really, really close to P on the left side, as long as it's not touching, again, they can be 1 millimeter apart. It's still two separate points. I can draw it. It gets really, really close to the red line, the tangent line. Okay. The language we would say is that the tangent line can be thought of as the limiting line. Okay, it's a line that gets approached as Q moves closer and closer to P, coming from both sides, coming from both the left side and the right side. Okay. Now, how do we find these slopes? We know how to find a slope, y2 minus y1 divided by x2 minus x1, right? A lot of this first section in 2.1 is just doing that, y2 minus y1 divided by x2 minus x1. Okay, so when we end up doing 2.1, okay, you're just bringing away a lot of slopes, which you already know. By the way, you might have to compute slopes on the test. We had some of that too. And if you forgot the formula of slope, put it down. Y2 minus y1 divided by x2 minus x1, right? Okay. What's going to happen is we'll have a graph sometimes. Okay. We want to know something about slopes of tangent line, rate of change of the function. Okay, you'll hear me say rate of change quite a bit. Okay, so I'm going to try to come up with a tangent line. Okay, so a line that just barely grazes it, maybe like that. And for this point, it's like that. And for this point, it's like that. So the tangent line keeps changing, right? So maybe like that, and like that, and like that, and like that. Okay. Might do it for this. Okay. And you can see what they're doing. They're just coming up with slopes. Y2 minus y1 divided by x2 minus x1. Okay. Don't look at the nitty-gritty details yet. Now, at the start, it's a tangent and velocity. How do we get velocity into the picture? Okay, on page 81, if you're trying to follow along. Okay, we know that average velocity is change in position divided by time elapsed. Okay. So what's my average velocity, right? So I start from home, I go to work. Okay, well, how far did I travel? Divided by how much time did it take, right? And that'll give me the average velocity. Feet per second, miles per hour, or something like that. Okay. So if I have a picture like so, you have here A and A plus H. Okay. So this is time, S is distance. Okay. Quite often we will use S, the letter S for distance. We don't want to use D because D is going to stand for derivative. Okay. And again, those of you who have calculus background, you know about derivatives. Okay. Those of you who have no idea what I'm talking about, don't worry, but we're going to say derivative, 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 derivative over and over and over. Okay, so we don't want to use D for derivative. So they decided to use, sorry, we don't want to use D for distance, we use S. So if I connect the secant line, secant joins 2 points, P and Q. Okay. This is my change in Y, delta Y divided by delta X. Now delta Y is a distance. Delta X is time. So what is distance divided by time? Average velocity. Okay. So the slope if I'm given a graph of distance versus time, slope of a secant line will be average velocity. Okay, the slope of the tangent line will be something called instantaneous velocity, velocity at an instant. Okay, slope of the tangent line. Okay, and yeah, if you want to put that on your cheat sheet, the next cheat sheet, you may. Okay, and I know right now, until after the test on Friday, you might want to just kind of half-heartedly look at this stuff, and then maybe look at it in more detail after the test. Okay, but slope of the tangent line is something called instantaneous velocity. Okay, slope of a secant line, average velocity. Okay. All right, so I'll introduce a little bit of this, not much, and then I'm going to give you something to do in class. Okay, so number 1 to 7 odd was the assignment, which is not that much, it seems, but there's a lot to it. There's a lot of computation in it. Okay, so offhand, it looks like there's only 4 problems, 1, 3, 5, and 7. Yeah, but there's a lot of part A, part B, part C, and even A1 and A2 and A3, so it's not as short as you might think. All right, so let's see what's happening here. A tank holds 1,000 gallons of water, number 1, which drains from the bottom of the tank in half an hour. The values in the table shows the volume of water in the tank after T minutes. Okay, so it starts off with 1,000 gallons, it drains, and here's some data. Okay, so after 5 minutes, I guess they took a reading every 5 minutes. So after 5 minutes, 694, after 10, 444, and so on, all the way to 30 is 0. Notice it does not go down in a straight line. It's not a straight line draining. And if you stop and think about it, that actually might make sense in some instances, because if you're talking about draining of the water, because of the force of gravity, there's more water on top, right, that wants to push it down, and so it'll drain faster. Okay, but then near the end, there isn't as much, pressure above it, so it's not going to drain as quickly. Okay, I don't know if you've experienced emptying a jug or emptying something from the bottom. It tends to go real fast at the beginning, but then at the end, it's not so much. Okay. So we just have to come up with a graph. Here's the graph. Okay, now what did I do? Okay, and I'm not sure I can show you both at the same time. I'll try, but I may not be able to. Get into trouble here. So I took all of these as ordered pairs. Okay, this is X, this is Y, and there's one that's not on the table. That would be 0, 1000, right? So 0, 1000. I took all of these, and there's the plot in red. Okay, so 0, 1000, 5, 694 is somewhere like that. Okay, so I did first quadrant. I didn't bother with second, third, and fourth quadrants because everything's positive, right? So 5, 694, 10, 444, 15, 250, and so on, all the way down to 30, 0. And you get a curve like that. So again, steeper at the beginning, as we expect. It should be steeper at the beginning and less steep at the end. Okay, and then they're going to ask us all these questions about this. So if P is the point 15, 250, find the slope of the secant lines where Q is the point on the graph where T is 5, 10, 20, 25, and 30. Okay, so what they're saying is take this point, 15, 250, and pair it with 5. So 5, 694. Come up with a slope. Okay. Do the same thing for 10. So keep 15, 250, and then 10, 444. And then keep 15, 250, and then 20, whatever, right? Okay. So this is my fixed point. 15, 250 is like the point P in all of these. Okay. And the point Q that keeps moving are all these guys over here. Okay. So that's what's happening. So that's what you're going to do for all of these from there. All right, so it's just y2 minus y1 divided by x2 minus x1. Estimate the slope of the tangent line by averaging the slopes of two secant lines. Okay, so the most accurate one would be the two closest ones. That would be like saying, estimate the slope of the tangent line. I'll take the answer I got for this one and average them, right? One's on the right side, one's on the left side. They should be pretty close, right? These are a little bit far away. Okay, so I wasn't going to do it, but I'll just tell you what to do is just do y2 minus y1 minus x2 minus x1 for all these. So I told you what to do, right? So keep 15, 250 for all of them. That's my fixed point. And then your second point is 5, 694. And in another problem, use this with 10, 444, and use the same point, 15, 250, with 20, 111, and then 15, 250 with 25, 28, and 15, 250 with 30, 0. Okay, and then the answer for B, part B, I would say average whatever you got for these two, right? The two close ones. So you got some slope here, you got some slope here, average the two. Okay, and I'll save C for next time. I was going to work that out with you tomorrow, but I think I'll stop right there. Okay. All right, so I'm going to stop and give you one to do in class, which was actually literally one that was on your homework. Okay. So in class, you can type your answer in the chat, and I told you how to type it. It's basically just problem number 71. Okay, so work out 71 just like I did 70 and 69. You say, I already did it. Great, just type it in, leave. You're done. Okay, so 71, sine of arctangent of x. Type your answer in the chat, give me a private chat, and then you're done. Again, for square root, type SQRT. Instead of the -1, put arc, A-R-C, like arctangent. Exponent, use the up caret, like x squared, x up caret, and so on. So sine of inverse tangent of x. I only feel like holding this for a few more seconds. Okay, so again, 71, sine of arctangent of x. And maybe I'll type it in the chat also. And, okay, so that's all I'm going to hold it for. Okay, so go ahead and type it. And when you finish, just type it in and you're done. See, I already did it on my homework. Then great, just type it in and you may leave. Okay, so I'll type it also in the chat. Okay, so I will stop recording.